Hello. I'll be demonstrating homework 6. I misnumbered in the homework in the previous video. So I will do homework 6 on data. And as usual, the data file is on Blackboard. If you download it, I will open this. So let's have a look at this. We'll open browser. And as you see, there are many countries, and like overall, there are more than 1,300 observations, but the number of countries is not 1,300. So, say for example, Zimbabwe has data on 70, 75, 80, 85, 90, 95, 2000, and like Zambia has the same. Uh, how many? 7 observations. So Zimbabwe has 7 observations. So like that, there are many countries, and some countries starts from 1960, but the previous country, like say this country, starts in 1985, and Uzbekistan starts in 2000. Maybe USSR, like I don't know when was the last year in USSR. Anyhow, so different. There are many countries, and the countries may have different time periods. So then we call this type of data unbalanced panel. It does not cause much difficulty in your analysis. So implementation is pretty much the same, but just I'm telling you it is unbalanced. Like Ukraine has only 1 observation. Uganda starts at 1970. So it's fun to read what's going on. Uh, Anyhow, so country is the name of the country, and year is year. Literally, it is a year. And there are democracy index, log of GDP per capita, and log population and age distribution, education. We are going to use democracy, GDP per capita, education. And finally, there is another variable, code. This code is the code for the country, code number for the country. This variable is a name, so it is not a number. That causes some problem in Stata. So the Stata can handle numbers for some operation, but it is not a number. So then instead you may use this. Say like Trinidad and Tobago is encoded as 182. It is a unique identification number for that country. And then, wow, there are more than 200 countries, 211 countries. It starts from 1. Oh, yes, there are more than 200 countries, and some data are missing, like Andorra. Andorra has some missing variables like this, so this also causes some problem. GDP per capita is not observed, and then so these missing variables also cause more unbalancedness. And Stata automatically removes missing variables, so you don't need to worry. And if you so implementation does not have much problem, but will be these variables will be deleted in the analysis. Stata will automatically do that. So okay, let's see what happens. I'm going to simply regress democracy index on GDP per capita using robust option. So this is the baseline regression model. So it seems like the log GDP per capita increases democracy index. So let's think about. Democracy index is a number between 0 and 1. I think 1 means completely democratic and 0 means completely autocratic, I think. And so then this means the regression results have a positive coefficient, which is very significant. The t statistic is 33. Remember, greater than 1.96 is statistically significant. It's like more, even like 15 times greater than the critical value. So p-value is obviously 0, and it's positive, which means GDP per capita, as GDP per capita increases, democracy increases. There is a tendency they are moving together. But like if you interpret that more carefully, remember GDP per capita is taken the logarithm, so you have to interpret this as a percentage change. So you remember how we interpret the coefficient in front of a logged variable. Democracy is not log, it's but GDP per capita is taken log. So like when you interpret this, you have to say something like this. When the GDP per capita increases by 1%, then democracy index will increase by a certain points. So remember what we learned in the previous chapter and apply the method, the same interpretation, how you interpret log variable in this case. Anyhow, it's very strong and interesting result. And remember, there are some missing variables. So in our original data, the number of observations was more than 1,300. But in this analysis, the number of observations used in this regression is only 958, because the other about like 300 observations are missing. So either democracy index is missing or GDP per capita is missing. So if either of them is missing, that observation is deleted in this regression to calculate the regression results. Okay, and just let's try another simple. I will just click robust. So you do this. I added education. So education is an important variable. So higher education implies maybe is positively correlated with economic development. Also, higher education is correlated positively with democracy, the democracy maturity. So as expected, education turns out to be very significant and positive. So also its p-value is 0, so very significant. And still GDP per capita has a positive coefficient, but it decreased a lot from the previous regression result. So previously the coefficient was 0.23, but now 0.14, about like say like how much is it? 1/3 has been decreased. So it's a huge decrease, and also significance decreased a lot. And it means something. So that means education was an important omitted variable. So the difference could be interpreted as the omitted variable bias caused by omission of the education variable. So education is the average education attainment in that country in that year. So this is an important variable. So far, it is just baseline regressions, just kind of review of what we have done earlier. Now we are going to start to use the panel data structure. Our data is panel data. We have countries and years. To do that, you have to first declare panel data. So longitudinal panel data, go to statistics, longitudinal panel data, setup and utilities, declare data set to be panel data. This is what you have to do first. So I will click this, and so you have to set what is the panel ID and what is the time variable. So you have to choose code. Remember, code was the country identification number, and time variable is year. And you may choose yearly, so you can define the time unit is yearly, but Actually, it does not do anything in this homework. So you may just put anything, but let's just choose it. And then so country ID and year ID. Then okay. Then you declared the data to be a panel data. So it shows your data is unbalanced. Your data is unbalanced, and year is from 1960 to 2000 with gaps. The gap means there are 5 year. The interval is 5 year, and there are some empty years. So for some countries, we observe, say, for example, 1970, but 80 is not observed. But then we observe 90 again. So some middle value may not be observed for many reasons. I don't know why. So anyhow, we declared the data structure, and now Stata will handle a lot of things just by understanding the structure. By the way, one thing I would like to say here is I told you country, there was another variable for country. It does not work. So if you write it this way, so if you declare the panel data structure using country and year, so replaced code with country, then the problem here is country is not recognized because it says it is a string variable. String variable means it's not a numeric variable. It is in letters. It is words. So it's a text. So it is not allowed in the declaration in this command. So therefore, we have to use code instead of country. So string variables are not allowed. And then now let's just try. Let's just see what happens if you still you may use the regression command as usual. There is no difference. There is no difference. Like after declaring the panel data structure, you may use the same command as before. There is no difference. It does not utilize the panel data structure. Also, you may use xt regress. Let's try this. If you use another regression, so this is panel data regression, panel data specific regression command, but using the same structure. There is no difference. Same dependent variables, same regressors, same robust command. And the results are different. I thought it would be the same. So it uses some different methods. Oh, it is unexpected. I thought it must be the same, but okay. I'm sorry about that. I was confused. I thought they would be the same. This is random effects GLS regression. Okay, it's different. This is a different model that I did not teach in the course, so please forget about this. I thought they would be the same. Anyhow, then, okay, I will stop the video here, and we'll continue in the next video from here.